Now for this question, you have to state significant figures of each one of them. So this is 2SF, this is 2,4SF, and that's 2,3SF. Calculate the amount of moles of sodium azide present. So number of moles is mass over mR. mR of sodium azide, that is going to be 22.99 plus 3 times 1401, so 65.02. So number of moles would be the mass. This is in kilograms, so you'll have to convert it to grams. Times 10 to the power 3, because we're converting kilograms to grams, means you're going to multiply by 1,000, divide by, so that should give you 1.107. So this value is to 2SF, so means that my answer should be 1.1 mole. This is to 2SF. Okay. Percentage uncertainty for each one of them. So let's do percentage uncertainty in mass. For this one, you need to convert to grams because both of them are going to be in kilograms, so it's going to cancel out. So no need for any conversions here. So you'll get 1.38%, and I'm going to give this to 1SF, so 1%. Percentage uncertainty in temperature. So again here, so that's in degrees Celsius. So no need to do any conversions. 0.5 divided by 20. That gives you 2.5%, and I'm giving this to 1SF, so 3%. Percentage uncertainty in pressure, that's going to be 1 over 106 times 100, so 0.948 and for 3, so that gives me to 1SF 0.9%. Okay, so all of this given to 1SF. Determine volume in dm cube produced under these conditions. So I'm going to use PV is equal to nRT. Now I will need to find volume. So volume is nRT divided by P. Let me state all the values that I have. For number of moles, I'm going to use the calculator value. R is the constant. T, this is given in degrees Celsius, so I'm going to convert that to Kelvin, so add 273, so that gives me 293 Kelvin. And pressure is given in kilopascal, and I need to convert this to Pascal, so times 10 to the power of 3 Pascal. Kilopascal to Pascal. So then volume would be number of moles times R times 293 divided by the pressure 106 times 10 power 3. And when I do this, I'm going to get the value in meter cube. So that's 0.0254 meter cube. Convert meter cube to dm cube. So I'm going to divide by 1,000. So that's going to give me 25.4 dm cube. Okay. So multiply by 1,000. Now I will need to find the uncertainty. So then for me to get the uncertainty, I'm going to use sum of percentage uncertainties. So that's going to be uncertainty total. I'm going to use calculator values, not the rounded up values. 943. So I'm going to use these original values. This is why I kept these values here, so that I can use them in my calculation. So I get 4.823%. So then the uncertainty is 4.823% of my volume, 25.4. So that gives me 1.23. So then the uncertainty is going to be 1 given to 1 SF. Okay, so that's the absolute uncertainty. Therefore, the volume is going to be quoted. So 1 SF, so this to 1 SF is 0 dp, which means that my answer for volume, this should be to 0 dp, so 25 plus minus 1 dm cube.